Hi guys. Um, I found a fix for the filament sensors on the probe. Uh, Apparently, when you're using an analog sensor or a digital sensor, you use different pin markers for the same pin. Rather, pin numbering or naming, it has been named differently. When you're using an analog, you just state it straight. Like if it's A3, it's 3, A4, it's 4. But for I found a solution in GitHub. Don't know if I'll find that. Can't remember I don't know if I'll find that page right now. Yeah, I found it. So it's this. Spare IO issues repeater. So this is what they say. Yeah, this guy have some features to control some additional things, additional funds and so on. You don't spare which I goes mapping mega to defines the pins, the numbers of Arduino, but not like they are defined the number of things. So that's the mobile. So what has helped me? It's this image here. As you see, this guy here. Many thanks for your play. So they just sent this image. I just took a screenshot of it. These are the numberings of the pinout on the RAM's board. So the ones that I've taken a close look are these ones. I want to start from here. Let's just start from here. There's a ref. So you have like PWM values running from 13 to D2. Then the US art running from D1 to D0, D14, D15, D16, D17, D18, D19, and then the I squared C pins, and then memory address pins running through from D23 through D37. The bits have gone changing, rather have gone shifting up. Just look at the pinout. So here are the analog pins. For analog 1, if you're using it as an analog, it's 0. But if you're using it as a digital pin, but still as an input, it's D54. For analog 1, no, that's for analog 0. For analog 1, it's D55. For analog 2, D56. Analog 3, D57. Analog 4, D58. Analog 5, D59. Analog 6, D60. Analog 7, D71. Analog 8, D62. Analog 9, D63. Analog 10, D64. analog 11 D65, analog 12 D66, analog 13 D67, analog 14 D68, analog 15 D69. Int 16. I'm not sure what this means. I'll do some research on this later. But so yeah, so I've come to on Marlin. Payload, I've put it at D57. So D57 analog 3. It was originally 3 here. And then for the probe, where is it probe now? I think the probe is supposed to be somewhere later. For the probe is D58. D58 is analog info. And then apparently I've inverted the logic for the end stop switch. Since I was using I'm just using a normal Windows switch. It's a 3-pin, but it's different from the normal one that I have. I think in the previous video you can see how it looks on the other side. You can have a look at this one. This is how it looks. It's roughly this type. Unpluggable, 3 pins, 5 volts, ground, signal. Same for here. 5 volts, ground, signal. The connector goes only in one way. The other ones that I have, the other end stops that I have is these ones. These are the ones that came with the this RepRap smart controller kit. Still the same, has 3 pins, 5 volts, ground, signal. But now these ones, when they invert in, it's false. This one is inverting is true. But since this and this are the same type, this and this are the same type, and on the code they are following the same logic for inversion, and the rest, the rest for the maximum and the minimums are the same, and they are following the same logic. I think there might just be a difference. Maybe they are pull-ups. I don't know. I'm not sure. Maybe I did them research well. I thought they were just the same because of the number of keyboards that it requires. So I've tested it out. I was actually on this section, but leveling. There's a section here they tell you the orientation of the bell. This is the back, this is the front, this is the left, this is right. So yeah, that side is the back. The minimum of the X is the back, the maximum is the front. The minimum of the Y is left, the maximum is right. So let me just come, we go through this together slowly. So start counter this. I've tried M19. it's open. Right now it's open. And then when I press, let me trigger filament. The filament is triggered. The probe is triggered. We have triggered. So having that triggered, so now I'm actually really close to start printing. The size of the bed has been defined. I've actually changed the size of the bed. Yeah. According to the new measurements that these are the maximum my threads can give me for at the moment. 110 for X, 150 for Y, 100 for Z. But I can achieve slightly more for Z. I can push it more. Yeah, but I can push. The other limiting factor that I have for the Z, and I'm not really sure how to say it, but the bag, it has a really big foot. This not, I don't know if I call it a foot. And then for the gantry, it has a really big, we call it kitambi, stomach. It's protruding. This thing is, it's protruding too much. It's a whole, I measured it in one of the other videos. It's a whole 120, 130 actually. You just do it roughly. A whole 130 hanging. And then for this, it's a whole 150, it was 150, yeah. 150. See? 150. So if I could just find ways, I have plans for future builds. One, I might reduce this because this is not really needed for strength in the just used for holding. I might stay with this, or I use one of these and then I'll remove this. I'll couple this straight on to this just to save on this. I'll rather use two of these despite them being long. That's more weight. I'll couple it straight on, one on this, and then the other one on the back one, and the other one, and then couple that to this, as I was saying, this plate. It's I think I have a sample somewhere here. It's roughly it's thin. It's thin. So if I cut this well, because cutting it tends to be, I don't know how I'll call this. Tends to, so using this in layers, I can like do these two layers here to save on this, and then this one will be coupled straight. So this one, this wood, which will be this one, because this is too thick, this is thick, as in you can roughly see it's thicker than this one. So I'll just use this, but I don't want to spoil this frame just in case I want to use it, just in case you just get. So I'll just use a wood like this one, roughly of the same size, and then the pulleys have a pulley, so it will be just like this, straight on for the two sides, here and here, and then two. So this will be two split, removing this, saving up on this space, and then so this will be one, this space will be the space for one, and then this will be replaced by this. I might laser cut it or CNC engrave it to get a good shape, but plus to save weight on this hollow part because I don't require, I just need the mounts, or I might even put it on a next shape to stay like this to hold my, I know, but you get, and then so that will roughly save a good 40 or a good 50 mm. And then for here, let me just show you what I'm planning currently at the moment. You already saw it, but it's just in the other videos. This is the 5-axis printer because I'm still planning on a 5-axis printer because of the supportless prints. It's not really, but yeah, still working on a 5-axis printer. I was thinking it will help me save up, especially when you're printing big objects. Supports will be bulky and that's a lot of material. So like this plane, like for the gantry, let me explain the gantry, then I'll show you on the 5-axis printer. Same for the gantry. I'll remove this wood, use this 2 plates of this, and then this will be just be the same, but it will be a constant one running down, connecting the upper pulley and the lower pulley, upper pulley and the lower pulley, and then this bolted to it, so it will save up on this space a little bit. Still thinking on this space. This space is still a lot even with that modification. So this type of pulleys consumes a lot of space, but yeah, it does the job well. So linear rails are just better. If you can use linear rails instead of this, you can save more space. And then for here I might change this to this, this to here. I'll cut it thinner and then make it something like this, because you see this mechanism, it's just been supported on another wood. Don't know if you can see it from this side. You can see it from this side. This is a perfect example. These are 3 plates. This is actually where I got the idea from, because this hot end didn't come with a mounting. It doesn't really have a mounting. I've seen people mount it from here, but me, I'm using wood. I won't mount something hot, and then so I'm mounting it after the cold end, hoping it holds. But I'm just gonna remove this setup anyway, and soon I'm gonna do some few prints and then go to this. Obviously this thing has impressed me because I've gotten it for, as I said, it was can't remember if it was 2000. It was a limited offer. It was actually the last one. I was lucky enough to get it. I can't. Let me just open it. She's interested in me that was. It does even come with a nozzle and a free silicone stuff. So yeah, I'm gonna install this. it has come with 2 mounts, I mean 3 mounts actually. Alafu, the other thing that has interested me about it, it's so compact such that even my extruder setup, I'll be forced to upgrade my extruder setup eventually, because see that it's that thing, it's that skinny. So I think it's really meant for a board and tube. I'm not a board and tube fan. This is my board and tube setup. You put the board and tube before the driver, and this is just because of humidity. You should even be putting this in an enclosure. I'm creating an enclosure. See, just next to tanks. So I might really require that humidity. Check. I have a set of sensors here. Oh, I didn't turn off the soldering gun. I have a humidity sensor in short. Somewhere here. This one here. I think it's this one here. I haven't seen support for humidity sensor in Marlin yet. I hope it's this one. I'm not sure, but I think it's this one. I was thinking of using it in a drone, but I might use it here. I'll just know about it later. But so, yep. This is the other thing that I need to consider. The size, that's an advantage. These are among those things that you say they are ahead of its time. It's interesting. V1 XCR WS -V1. It's really compact. Okay, it's roughly the same size in this dimension. Considering the fan over here. Yep, it's definitely smaller. Yep, after excuse me. So I think you're ready to do the bed leveling. I've explained the filament sensor and the probe, so I'm not sure how the bed leveling will go, but you'll only know once you try it. So let's try it. Oh, I forgot. Now what I was saying, you can see here for the gantry it's thinner. This is a normal load. This is 1.8 mm thick, and then the gantry, these are 3 plates thick sandwiched. So I just extruded a 9. It's a 9 constant. It's gonna be a 10 obviously, something, but yeah. And then same for here for the arm. This section here. At the moment I was drawing it, I drew it like this and then cut it. This is just a single piece at the moment. I was just doing it for easier simulation. I want to plant this into MATLAB. I just wanted a frame to hold everything, and then what I think is redundant at the moment are these, the axes, the and I'm not sure how they are called, NR or NC, the linear rails, NR something, NR2, NR something. I think they're redundant. I didn't really need them. I could have just bolted this thing straight on to the frame, and then so this is the X, this is the Y, this is the Z, this is A, and then this is B. This thing is still, I don't know, we can't see it rotate at the moment. I don't know why. Maybe I just rotate it from here. So yeah, you get, so even the other parts that I'm using, that thin board part, it's this one for the X. I have seen this. So this one for the X. This the support, the resin support. I'm not sure if they are 2 plates thick or 3 plates thick, because you know it's mostly holding linear. There's no swinging of the bed mostly. So I think it was, if not 3, it's just 2. I think it's 3 plates. So this and this is a plate. Even this is a plate. Oh yeah, this is 3 plates. This is 2 plates. This is 2 plates. You can see it clearly. This is 3 plates because it's gonna hold something. It's holding something on this axis, or something on its bed. I'm not sure which term to give it. So that's the plan that I have to reduce weight. Obviously, that's to increase speed and reduce power. Yeah, let's get to bed leveling. Apparently, just so you know, it's the first time I'm planning to do this stuff. I'm not even sure full sizes of the bed. Done. Bed leveling section, calibrate. Choose one of the options below to enable G29 bed leveling. The parameters and behavior of G29 will change depending on your selection. If using a probe for Z homing, enable Z safe homing also. You're not really using a probe to home the Z, but it seems it's an option. I just want the probe to be for bed leveling. Homing will home it's the end stop. I haven't removed the end stop, so yeah, I'm gonna leave that stay. Auto bed leveling 3 points. I think this is the first one. Probe 3 arbitrary points on the bed that aren't collinear. You specify the XY coordinates of all 3 points. The result is a simple tilted plane best for a flat bed. So if you have a flat bed, if you are assured your bed is flat, 3 points is for you, and then it will approximate and then auto bed leveling linear, probe several points in a grid. You specify the rectangular and the density of the sample points. The result is a single tilted plane best of a flat bed. So you specify the rectangle, unlike the triangle, and the density of the sample points. So maybe how many mesh points there are there, how many triangles in the short, not how many rectangles are there. The result is a single tilted plane. Yeah, it can be tilted at 0 degrees if you are good, if you are great. Best for a flat bed. Auto bed leveling by linear. probe several points in a grid. You specify the rectangle and the density of the sample points. The result is a mesh best for large or uneven beds. So I think this is the same as out of bed leveling linear, just that this is for uneven beds. Out of bed leveling, UBL, undefined bed leveling, a comprehensive bed leveling system combining the features and benefits of other systems. UBL also includes integrated mesh generation, mesh validation, and mesh editing system. Probe a grid manually. Mesh bed leveling. The result is a mesh suitable for large or uneven beds. See bilinear. For machines without a probe, mesh bed leveling provides a method to perform leveling in steps, so you can manually adjust the Z height at each grid point to your large control. The process is guided step by step. So if you have no probe, this is for you. You just measure the tips. I think it can work if you have a probe, but you still measure the... I haven't gotten that quite well. Auto bed leveling UBL. This seems to be a complicated form, a more advanced form of bed leveling than auto bed leveling by linear. Auto bed leveling by linear, it's the same as linear, it's just that it assumes the bed is not even, so I think it has more points. I think you should specify more points for bilinear for you to get better results, maybe. And then this one is if you have a flat bed or a short. I think I have a flat bed. My glass, it's a glass, and you can't be that accurate. Let's see. You're moving by millimeters here, so I'm mostly being limited by these things, which have gone out of line. I'll have to realign them because either way I need to move my bed slightly to the back for me to get some more space because of my limitations of my axis. Yeah. So let's start with this one. I'm not sure how I'm gonna access this normally, so let's first remove this before we forget it. I'm gonna carry BG29. I think this is the code. Bed leveling. The parameters and behaviors of G29 will change depending on your selection. So, okay, where is this front interface? So we go to front interface, disconnect, upload. Let me just leave the power supply on. And let's watch it upload. Okay, so you have an error. Can't open device com. Apparently front interface isn't disconnected. I have a problem with my mouse. Okay. Connect. But what you do know G29. I'm not sure if it's G29. Copy. Either burn it or make it. Yep. Processing power supply is home XYZ first, or into home. Let me do the auto home. Yep, you're just gonna have to wait. Eating some tropical. Bed swing, and it has apparently improved. I realigned it a bit. And I quite haven't applied lobe yet. Should lobe this thing. Let me lobe it. Let me lobe it. It hasn't crossed over this side, but the limit switch has gone off. So the play is starting from here. I don't know if I told you, at one moment when the motor was connected on this axis, I kept soldering here because it was sticking. I was just using a saw. Going where it sticks, you just go through and cut the gantry, not the frame. The tolerance on this side was tight. As you know, it was the frame was 3D designed. It was designed on CAD, so. But I didn't consider this. I didn't think it would be this much. This is the one I didn't follow CAD on the bed. The bed just came along, but the frame was the country, as in the basic idea was although it's moving. It's moving again. It's moving twice. I think this is the second time it's moving. After I've pressed the, apparently this is among the first time this button has worked fully. It's done. We can now, okay, I think I've seen no problem, but I've set the offsets of the probe, because that probe is seriously hanging out. G29 send. See, I've set the offsets. Apparently, I think it will probe outside the space. Okay, my Z is set, but the probe is still going down. So yeah. I think I'll just have to hold it with. I might just terminate it. Let me terminate it. Do my. That's the first trial. Let me make the video short. So what I'll do, I'll check why the offsets are not there. And then after that, I'll be back. So yeah, let me pause. We continue from there. Let me pause this print and then I'll give you feedback on the results. So yeah. So I've changed to the offset. Apparently they're not how I'd quite visioned them. First of all, 0, 0. I thought 0, 0, the initial point is at minimum. That will be on a printer. On my printer, since this is the X minimum, now for this is the Y minimum, because that's how it's moving according to printer face. By the way, I've marked out my printer using according to how printer face is moving my axis. So originally I thought this would be X, and then this is Y. I thought my Cartesian plane is going like this, but my Cartesian plane is going like X, Y, Z. X, Y, Z. So yeah, this is X, this is Y, this is Z. So according to this stuff, this is left, this is right, this is back, this is front. This is 0.00. So my 0.00 is somewhere here. It's at minimum, it's at X maximum, Y minimum, Z minimum. That's for 0, 0, 0. And then so my probe is 60 mm to the left. So they are saying to the left. The other thing that I've seen a difference is this X probe. I know this to be my X. Now they are saying this is X. This is the left. Ama the printer is being faced. How is this printer facing? Left. So that's according to this down diagram. It's not how I've labeled it. This will be left. This will be right. And then this is front. This is back. It's inverted. Oh, thank God it's inverted, because if it was two axis inverted, it would be even more complicated. It's fully inverted. So let me repeat again. This is left. No. Since 0, 0 is this point, this is left. To the left, X. Yep, this is the X. It's sort of inverted. I'm not really sure, but somewhat it's inverted. Hope you understand what I mean. But if it's to the left, as it's to the left, you put negative. So it's to the left of the nozzle. But I'm just gonna try. I'm not really sure if I'm gonna go back. Originally this was 60. This was 0. X offset was 0. Y offset was 60. So yeah, the probe was somewhere here, and then it moved here, and then when it here, I cut off. It actually moved up to here, and then it probed here, and then the probe is sort of short. I'm gonna add this angle. I think I'm gonna add this angle and then compensate it with an offset. I think it's easier because of measurements. You get it? Make this longer to touch some place longer, and then I measure when it's touching, fully touching the offset of the nozzle to the bed. That's a better way than actually keep on aligning it with the eye as we have been doing under a piece of wood. So yeah, see, to change that, main probe gauge. Certain types of probes need to stay away from edges. Let me just probe at the 0, 0. I'm gonna change things slowly, one by one. But I've started the offsets. Let me go now for this. This needs to go low. I need like a 40 or a 30. Let's try 40. 40 seems good. I'm looking for a 40. I think I might even go for 30. 30 might even give better results. But yeah, so disconnect. I'll first test the probe height. Upload the code. More tropical mint. You have an error. In file included from marlin configuration H. I need someone to check static assertion file. What does this mean now? The probe is outside the region, so I thought it's supposed to compensate for that automatically. Let me check on this and then I'll get back.